Okay, I want to set up a random sample of the numbers 1 through 9. Again, the population is discrete uniform, so I ask you to write something like discrete uniform 1 through 9. That'll work. And we can move that side to side, the width, just fine. So I can get that width, and then to sample from a 1 through 9 uniform discrete distribution, we've got a very easy way in spreadsheets to do that. That's the ran between. If you type it in, you can probably also get the little description. It says returns a random integer between the numbers you specify, so I would like one between 1 and 9. And so I type that in, I hit enter, 5. That's between 1 and 9. And now, I need to copy and paste that down to here. Again, I could do something like copy, and I could highlight this whole thing and then say paste, and that will do it, and I have those random numbers. Now, what I also might want to do is just everything that's going to be in this column, maybe center it, and so I can see it a little better. I sampled from the population 9 times. There are my results, and of course, I got a 1. I didn't get any 2s. I got a 3. Didn't get any 4s. Got a 5. Didn't, and then got 3 6s, and then a 7, 8, and 9. And so that's very quickly how we can do that. And then we want our descriptive statistics. We want the sample mean. Now I think I just tell you to put mean. You could also do something like sample mean, so you remind yourself it's the sample mean, and similarly the sample standard deviation. And to get those, the mean in most spreadsheets, that's the word average. So I say average, and I need these cells. So after I type the open parenthesis to get my input, I highlight all those, and notice it just updated A2 through A10. Then I close that parenthesis. So I needed that equal sign because it is a function. It's calculating something on the spreadsheet. In order to do that, you need an equal sign to start things off, and then the name of what you're trying to calculate, and then the range of cells or any other inputs you have to give. So I do that, hit enter, and I got looks like 5 2/3. And sample standard deviation, same idea, equals. And this is ST. Now, if you look down here, as you type, you might get various options. And so one of them is STDEV, and that's the one I want. That's the sample standard deviation. But now there's also the population standard deviation, which is different. It's different by a constant, and that's in our reading and other work. But I just want the sample standard deviation. That's the simple one. It just STDEV. And again, I need what I'm working on, so A2 through A10. I could also type those in, but I find I'm a lot less likely to make mistakes as to where I'm trying to get my data and so forth if I highlight. And again, close that off, hit enter, and I got a sample standard deviation of 2.5-ish, 2.449, 2.45, something like that. And now I can make 5 copies of all this very quickly. Now it's kind of funny, if I click this, I think if I pull it this way, notice what happens. It makes that a 10. Okay, I don't want a 10. I want a 9 because it's still discrete uniform 1 through 9. Okay, so I filled that in, but I'm gonna get rid of it. So in this case, in my case for this, the easiest way for me to copy this is probably do a copy and fill in for more. There's a paste. And now if I was really quick with this, I think, let's see, you know, you can find various things in here. Column width. Okay, so I right-clicked and I found column width, and well, that's default value. Yeah, I don't know. I think in some spreadsheets you could go with, you know, come up with it automatically, and it would come up with what you need. Now another thing you can do is, right, I had done this one, is I move it. Oh, well, that's interesting. I thought as I moved it, it would tell me how far, what the width is, but it's not doing that. Okay. Well, again, every spreadsheet's different, so I'll just kind of do this until I get all of these, and I've got this blown up a little big so you all can see it on the screen really well, and maybe so I can too, because I'm getting old. But now once I've got those column headings, everything else here I can actually just fill in by highlighting everything and dragging it over. Oh, that's my grandson crying in the background. He didn't get a nap today, so he's not too happy. So we have our sample means, and notice they're different. That's the point of this little extra. Well, one of the points is to be able to sample or simulate sampling from a particular population. But the other point then is to see that when we do, the samples are different. They don't all look the same. Heck, here we got 4 4s. I mean, that's quite a bit. And I wouldn't typically expect to see that. But in each case, right, we've got different means. Yeah, none of those means are the same. They could be, but none of them are. And none of the sample standard deviations are the same. So those are all different. And again, this is a big point, is that my population should have all the numbers from 1 to 9 equally represented. Yet, when I go to sample them, they are not equally represented. Even though this was a random sample, the computer does a very nice job of simulating just a simple random sample, and they're different. So, you know, that's something to keep in mind. That's the big picture item here. That's a huge takeaway, is that we got a different sample mean in every case. Again, we didn't have to, but we did. And we got a different sample standard deviation, even though every single one of these, all 5 of these, are from the same population. Okay, so that's good for that video.